Next topic is cross-domain messaging. So here we are going to cover the concept of single origin policy called SOP or SOP. And we are going to talk about HTML5 cross-domain messaging, and then we are going to cover the concept of what is called the cross-origin resource sharing standard and XML version 2. XML HTTP request version 2. So this is the next version of XML HTTP request for handling the AJAX request. So let's talk about single origin policy. So what is single origin policy? So single origin policy basically does not allow JavaScript code loaded from one origin accessing or communicating with documents from another origin. So in other words, documents retrieved from different origins are isolated from each other. Okay. So as we are going to talk about it in the following slide, this is to prevent cross-site scripting, the security attack. Okay. JavaScript code are considered, or documents are considered from the same origin only if they are loaded from the sites that have the same protocol, host, and port. Okay, and protocol could be HTTP, HTTPS, or WS or WSS. Okay. By the way, this single origin policy is imposed by browsers, meaning browsers are imposing this single origin policy as a built-in feature. Okay, so there is nothing you can do about it, right? Like in Chrome, but you can actually disable it. But when you're actually starting the BROM, by specifying disable security or something like that. But that is actually for in general not recommended. Okay. Okay, so let's talk about single origin policy examples. Suppose we have a JavaScript code or document from let's say store.company.com, that is the host, and directory is dir and the page.html. Can access the following documents since they are considered from the same origin. So here they are coming from the same host and same port, same protocol, and same port. Okay, so this dir page.html should be able to access these documents, okay, because they are considered from the same origin. However, it cannot access the following documents because these are considered from different origin. So in this case, this JavaScript code here cannot access this HTML file because it's actually using different protocol. This guy is using HTTPS instead of HTTP. This guy is using different port. Okay, so it is considered from a different origin. So this JavaScript code in this page cannot access this page. And it cannot access, of course, this is typical example that we are actually talking about in a different host. Okay, so this is considered that this is different host. So this guy cannot access documents of this. Okay. Okay, so why single origin policy is built in the browser in the first place? This is basically to prevent cross-site scripting security risk. Okay, in cross-site scripting risk, basically attackers inject some malicious JavaScript code into web pages, and when other clients access that page, they are not really aware the security risk. They just kind of grab that, access that page, and they will be attacked, okay, by that malicious JavaScript code. Okay, so basically by imposing single origin policy, you are eliminating this cross-site security risk. Not completely eliminating, but reduce significantly. So what is the downside of this single origin policy constraint? Okay, so single origin policy makes it hard to do mashup. Okay, because it disallows your XML HTTP request object from accessing documents from different origin. Okay, so what if you want to actually access, so you have a JavaScript code loaded from server 8 to access data from Flickr, Google, Yahoo, and through AJAX call. Okay, a single origin policy would not allow this kind of access to documents in different origin. Okay, SOAP-based security model of HTML is built in the browser, as I said before, and is actually introduced in early version of the browser, Netscape Navigator 2.0. Okay. However, it's becoming a hindrance of writing this rich client application, which wants to actually, access different documents from different origins. So there have been some workarounds, and these are not really desirable solutions. Okay, so client asks the server to access the document on behalf of it. So basically, instead of client talking to a different server directly, it will actually talk to the server it came from, and then the server will access the site on behalf of the client. Okay, so obviously this is not really efficient. Okay, there is another workaround called the JSON-P. Okay, and it's called the JSON padding, and it is actually really a hack. Okay, and it also has some security concerns. So there is not really good workaround for bypassing this single origin policy constraint of the browser. Okay, so HTML5 came up with some solutions to deal with this single origin policy constraints. Okay. The first constraint, issue number 1, is a document running in window A or iframe A cannot access document running in window B in iframe B. So in many cases, you might in fact have a window in your page, and then you have a frame inside of it, right? So those two are considered from different origin. Okay, so they cannot access each other. Right? And this could be pretty inconvenient, right? So HTML5 solves this constraint through what is called the cross-domain messaging. So in HTML5, window A, which contains iframe B, they can actually send messages back and forth. Okay, so they should be able to communicate. Issue number 2. This is a constraint number 2 imposed by single origin policy. A document loaded from origin A cannot access service running in origin B through traditional XML HTTP request. Okay, so this is a constraint, and HTML5 solved these problems by supporting a new standard called the cross-origin resource sharing, called the CORS. And the next version of next generation XML HTTP request version 2 is in fact CORS enabled. Okay, so we're going to actually talk about what the CORS and how it works underneath in a few minutes. I just want to give you a big picture here. So there are 2 constraints that are solved in HTML5. Okay, the first one is cross-domain messaging, and second is using CORS and CORS-enabled XML HTTP 2 version 2. Okay, all right. Let me actually stop right here and see whether you guys have any. Okay, so we're going to deal with the first issue. So we're going to actually deal with issue number 1 and how HTML5 solves it through cross-domain messaging. So that's the first thing we're going to actually talk about. Okay, so cross-domain messaging. So what is and why cross-domain messaging? So before cross-domain messaging in HTML5, communications between iframes and windows and tabs are disallowed by browser. Okay. So again, they are considered as different origins. Okay, so again, this is in order to prevent cross-site scripting security attack. Okay, so cross-domain messaging enables secure cross-domain messaging across iframes, windows, and tabs, regardless of the origins of the documents they loaded. Okay, so these iframes, windows, and tabs can send and receive data to and from other iframes and windows and tabs of different origins. Alright, so this is an example. So this is the body. This is a hosting window, and hosting window has it hosted iframe. So this iframe, I assume most of you actually understand what the iframe is. If you don't understand iframe, just let me know later on as a question. So this iframe you can think of is actually inside window of inside this body. Okay, so without the cross-domain messaging support in HTML5, this guy and this guy are considered as 2 different domains. Okay, so this is, this is loaded from server A, for example, but this iframe is actually going to different location here, domain 2. So they are considered as different domains. Okay, so that's the reason, the script code cannot access this iframe. Okay, so by using cross-domain messaging, now they should be able to communicate. Okay, so here, if you take a look at the code in this hosting window, is trying to get the iframe object. So go to document get element ID iframe. So this is the ID. Okay, and then is going to send message to that iframe by using this cross-domain messaging. So you can call post message method, and this is a message to post, and this is the target origin. So you specify where you want to send this message. Okay, all right. Now, receiving message from the iframe. So basically, the way that you can receive a message is either they actually use the same programming model. The iframe can actually send the message using post message, but in order to receive messages in both, okay, they use the onMessage event handler. Okay, so add onMessage event handler, and then event handler receives event which contains data, origin, and source properties. So in general, you need to check the origin to make sure the message is from the trusted origin or origins. Okay, so basically here, when the host receive a message from the iframe, okay, so add event listener, and you actually add the onMessage event listener. So this is event handler. Okay, here, and the first thing it does check is whether the origin is in fact a trusted origin. Okay. If it is not, then you can discard it, and if it is from a trusted origin, then it can access the e-data, and it can do whatever it wants to do. Okay. All right. So let's do exercise 1, cross-domain messaging. So let's open the documentation. All right, so here we are going to start the 2 HTTP servers because we want to simulate 2 different domains. Okay, so if you run HTTP server, that is running on port 8000. Okay, and then we are going to run HTTP server 8001. So that's running on port 8001. So we have 2 different HTTP server running on 2 different ports, so they are considered as 2 different domains. Okay, so that's what we want to do first. Okay, so let's do that. So here messaging, and let's run okay, so it's running on port 8000, and then we are going to run the HTML5, and then we are going to run 8001 bat. So it's running on port 8001. Okay, so we have a 2 HTTP server running on 2 different ports, simulating 2 different domains. Okay, all right. Now we are going to open this page. So this page, you can see it is coming from port 8000. Okay. So post message parent. Okay, so let me actually show how things work, and then I'll actually explain what's going on. Okay, so internally it has iframe. Okay, so this is a parent domain, which is HTTP localhost 8000, and this iframe is actually from 8001. So they are 2 different domains. Okay, so what we want to do is we want to send a message. So if I'm going to click this button in the iframe, is going to send a message to the parent, and parent receive the message and it will send back. So let me do that. So click the message. So the iframe send the message, and then the parent receive it, and parent will actually send back this message, and then iframe receive and display. It also actually trigger the parent to resize this iframe. So that's basically what happens. Okay. All right. So let me show you how things are done. So here, this is the post message parent HTML. So this guy. Okay, and again, this is actually loaded from the port 8000, HTTP server 1, domain 1. Okay, so and then we have an iframe, which is loaded from 8001. So they are certainly from a different domain. Okay, so when if you take a look at the iframe, so if you take a look at the post message iframe HTML file, okay, when the send height is actually clicked, this function will be invoked. This function is basically calling a post message method, okay, and the information is sending to the parent, meaning hosting window, is height and a greeting message. Okay, so hello from iframe. Okay, all right. So when that message is sent to the hosting window, it receives it using this function. Okay, so it checks whether origin is the target origin, meaning is something that it trusts. Okay, because it trusts so this is not. Okay, so if it is not the trusted domain, then it will just ignore it. And if it is trusted, it get the data from eData, so it will get the new height. So it will actually change the iframe's size. It will change the height. Okay, and then it will just display the message that came from the iframe. Okay, and then it will send back the message by saying hello JPassion.com. Okay, so when this message sent to the iframe will receive it again in the same way. So this is the on message event listener. So again, it checked whether it is target origin or not, so which is actually 8000. Okay, that's a parent origin, and then it basically display this message received from home page, and the data can be accessed through e.data. Okay, all right. So hopefully that gives you a sense of how things work. So I'll give you guys about the 10 to 15 minutes, depending on how much time you need, to try exercise 1. Okay, so next topic is cross-origin resource sharing, which is called CORS in short, and XML HTTP request version 2, which is enabled with the CORS. So what is CORS? So it is a W3C specification standard that defines how the browser and server must communicate when accessing resources across origin. So right now it's being supported pretty much all the modern browsers. So currently it's supported by most browsers: Internet Explorer 8+, Firefox 3.5+, Safari 4+, and Chrome. So the browsers you are using, pretty much all CORS enabled. So the basic idea behind CORS is to use custom HTTP header to allow both the browser and the server to know enough about each other to determine if the request and response should succeed or fail. So basically, this is to address the limitation of the JSON key hat. Okay, so as you're going to see later on, the client will send the information to the server, indicating it is a CORS enabled, and it does in fact send its own the address and stuff like that. And then so I'm gonna actually show you in the following slide. Okay, so it's used when the server doesn't require cookie or session-based authentication to expose data for universal access. So what we want to do is that we want you developers to be able to access the public websites such as Google or Yahoo or the Facebook to access the data or the services they provide, right? Without the authentication. Okay, so this is how things work. So HTTP request coming from the client is sent with the extra header called the origin. Okay, and this origin header contains the origin of the requesting page. So it should contain protocol, domain name, and the port. So it's going to be typically HTTP and JPassion.com, then port number 8000 or something like that, so that the server can easily determine whether or not it should serve the response. So the server will actually take a look at the this origin. Okay, so this is like http abc.domain1.com, and then server will determine whether it will allow the page to whether it should serve the response. Okay, if the server decides the request should be allowed, it sends the access control access origin header. So this is in the response from the server. Okay, echoing back the same origin it was sent, or star if it is a public service. So if it is a public service, meaning it's a Yahoo or Google, or Flickr, they will actually typically use star, meaning it wants to allow access from anybody. Okay, so if this header is missing or origins don't match, then the browser disallows the request. Then what it means is, if header is missing, meaning if this header is missing or origins don't match, okay, then the single origin policy of the browser is going to be applied. Okay, so these are examples. So the server says access control allow origin. And then the browser will actually check whether this is the same that from the request, and then browser will allow the access. Okay, or typically the public site will use the star. Okay, meaning anybody should be allowed. Okay, so hopefully this makes sense. So again, if header is missing or the origins don't match, this wildcard should always match, right? Don't match, then single origin policy of browser still gets applied. All right, that's course. Okay, let me actually finish up the presentation and hands-on lab, and then you can ask questions. Now, XML HTTP request version 2. Modern browsers create course-aware or course-enabled XML HTTP request object called the XHR2 and origin header. So they will actually create XML HTTP request with the origin header automatically. Okay, so if the course-enabled server sends back the access control allowed origin header with a proper value, then the browser will allow the cross-domain access. Okay. So this is the how you're gonna create XML HTTP request here, and then basically get, this is the URL, and then this is the when the response comes back, it will do something. So basically this XML HTTP request should have this origin header automatically. Okay. So issues of course is not yet available in all browsers. Okay, so we are talking about really old browsers. Okay, there are many existing services that don't yet take advantage of the specification. So one is on the client side, meaning old browsers, and the other issue is on the server side. The server is supposed to be able to actually handle this course by sending back this access origin allow origin header back, right, with a star typically. Okay, so if the server does not handle that one, then this course enabled communication would not work. So which means a single origin policy still get applied. Okay, so let's take a look at exercise 2. Exercise 2. So here, this is pretty straightforward exercise. What we want to do is we are going to so you go over here, so go over here, and basically it send a message to this update HTML5 rocks.com. This is a course enabled website. Okay, so we are going to take a look at the packets. Okay, so we're going to actually refresh one more time. Refresh. So now we should be able to take a look at this guy, and we are going to observe. So here we should actually see origin. What is the origin? Request header. Okay, so let me actually take a look at the lab documentation. So with this is, oh yeah, we have to take a look at this guy, not this guy. Yeah, so update HTML rocks.com. Okay. So refresh. Yeah, this one. This is the one that we want to take a look. So you can see the request has origin here. So origin says http:/localhost 8000, and the website that is course enabled. It should actually return the how can I get it should return response. Okay. Oh, wait a minute. Why can I actually see that? Let me again take a look at the lab documentation. Oh, okay. So it should actually have access control origin star. And so we actually sending. You create the new XML HTTP request object and response headers. Yeah, so response to course. Yeah, so we can even take a look at this guy from the log message. Yeah, okay, so that is this guy. Response from course request. Okay, so let's try one more time. Yeah, so response from course request, HTML5. So why I don't actually see. Oh, this is actually non-modified, so it's actually cached. That's why. Let's see how can I actually do this. We are going to go over here. Yeah, so now click this guy. Okay, now, yeah, so, you know, the reason I was not being able to see it is because it's what cached, so it didn't actually capture it. So I actually, you know, go to that website, I went to the page and then started again. So now you can see access control allow origin star. Okay, so that is what you're going to see. All right, so I'm going to give you guys about 10 minutes to try this exercise, and then we are going to move on to the next topic.